Welcome. Dear students, today we are going to study about Sandmeyer's reaction. When studying Sandmeyer's reaction, we will first study the purpose of Sandmeyer reaction, then we will look into the reaction, then we will have discussion on its mechanism, and then we will discuss about its applications. So let us start Sandmeyer's reaction. The purpose of Sandmeyer reaction. The purpose of Sandmeyer reaction is to introduce a halide group into an aromatic ring and to make a aromatic halide. I repeat, the purpose is to introduce a halide group into an aromatic ring. Okay, we can also introduce a nitrile group into an aromatic ring. So what we ultimately get or what we ultimately prepare is an aromatic halide and you can say aromatic nitrile. So you can put this X as anything. Okay, Cl, Br, anything. Okay, if it is Cl, it is chlorobenzene. If it is Br, it is bromobenzene. And this is benzonitrile. So Sandmeyer's reaction is used for the preparation of aromatic halide and aromatic nitriles. If you want to introduce a Cl group or any halide group into aromatic ring, you can well use this reaction. So that is the purpose. The second question is, how do we do that? How do we introduce a halide group into an aromatic ring? For that, we will have to see its reaction. So let us go to the reaction. Reaction. The substrate that I am using it for this is benzene diazonium chloride. This is benzene diazonium chloride. Now you treat the solution of benzene diazonium chloride with cuprous chloride, okay, and you heat it. So the product that you get, if you are using cuprous chloride, then the product that you get is a chlorobenzene, and of course a nitrogen gas is also evolved. If you are using cuprous bromide and if you are heating it, you get bromobenzene and above like that N2 gas is evolved. If you are using cuprous cyanide, then you get heating it, then you get a benzonitrile and N2 gas is evolved. So depending upon what you use, you get the product. What you have to do? Treat the solution of benzene diazonium chloride with cuprous chloride to get chlorobenzene. If you are treating it with cuprous bromide, you get bromobenzene. If you are treating it with cuprous cyanide, you will get a benzonitrile. So in this way, you can introduce a halide group into an aromatic ring or a nitrile group into an aromatic ring through this reaction. To better understand this reaction, let us see what is the mechanism of action. Let us see what is the mechanism of this reaction. If you are asking me the mechanism in a single sentence, I would say, let me write first, mechanism. As I was saying, if you are asking me the mechanism in a simple way, I would say it is a free radical nucleophilic substitution reaction. Aromatic substitution reaction. Aromatic substitution reaction. That is a mechanism of Sandmeyer reaction. Okay. The free radical nucleophilic aromatic substitution. That is a mechanism of Sandmeyer reaction. Please do note this. We are going to prove how it is a free radical nucleophilic aromatic substitution. So let us now come to further more into the mechanism. The mechanism involves 3 steps. It involves 3 steps. I am going to write the step number 1. Step 1. Formation of benzene free radical. Formation of benzene free radical For this I am going to use the diazonium, benzene diazonium salt. Okay, I'm going to, this is the benzene diazonium salt. I'm going to write it as, this is the benzene diazonium chloride, of course, and basically what happens is N is electronegative and it pulls the electron of the benzene ring, so there is sufficient electron density around benzene, so it doesn't require chlorine anymore, so chlorine is out, so you get N2 plus. You can write N2 plus like this, okay, as you wish. Okay, you can write it like this. Now think, what is the catalyst that is used in this reaction? It is, suppose it is cuprous chloride. Okay, we are going to make chlorobenzene, so we are going to use cuprous chloride. Now cuprous chloride also Cu plus will be formed because chlorine is electronegative and metal usually give the electron, so chlorine negative is formed and Cu plus is formed. So now we got the cuprous ion, correct? So we are going to react it with cuprous ion, right? Cuprous ion. Now cuprous ion have a tendency, they have a tendency to give an electron, to donate an electron, because when they donate an electron they become cupric ion, and the cupric ion is more stable than cuprous ion, because cupric ion can form stronger bonds with water. It has got greater hydration energy. Why cupric ion can form stronger bond with water? Because cupric ion, that is Cu2 plus, have greater positive charge, so it can form stronger bonds with a polar solvent like water. So that is why it has got greater hydration energy. So to become a more stable ion, what it has to do? It has to lose an electron. So therefore the cuprous ion loses an electron. Correct? So when it loses an electron, what will be formed? What will be formed? Yes, Cu2 plus will be formed. Absolutely right. Absolutely right. When Cu plus gives an electron to this, you get a diazonium free radical or diazo free radical. Correct? You get a diazo free radical. That positive charge will go and you get a diazo free radical. Now this free radical, this single electron, what it will do? It will pull this electron from here. Correct? So suppose if this pulls this electron, one electron is left here. Correct? And this electron, it goes here. This electron, it comes here and they form a bond. So what now you got is a benzene free radical and nitrogen gas, right? So you can write it like this. So you get a benzene free radical in this way. Let us now go for step 2. Step 2 is free radical nucleophilic substitution. Let us see what happens. Now we have got the benzene free radical and there are a lot of chlorine in the system. There is a lot of chlorine in the system. You know why? Because when it was benzene diazonium chloride earlier, a lot of chlorine was lost, and from cuprous chloride also lot of chlorine was lost, and we reacted cuprous with your benzene diazonium salt. So a lot of Cl minus is lost in the first step itself. So there is a lot of Cl minus. I am going to remove this negative sign. I am going to write it like this. Okay. Now there is one electron short in benzene ring. Am I correct? Usually what would be the scenario? Here there will be N double bond N. That was the scenario earlier. But now one electron is less. So here there is a positive charge, right? The benzene, actually here there is a positive charge here and it requires an electron. Okay. and this is a positive charge, right? And this is a nucleophile. This has 2 electrons, so it is a nucleophile. I removed that negative sign and I have written like this. So this is a nucleophile. So the nucleophile, what it should do, it should go and attack the positive area. So it will go and attack. But when it attacks, what would happen? There will be, suppose it attacks here, okay, the chlorine attacks here with its 2 electrons. So there are now 3 electrons. So that won't be right to make to make a bond. So one of the electron will jump off from here. It will go from here. Correct? So that is the situation. So what we will get? We will get a chlorobenzene and one of the electron which jumped from here, that is electron. Okay, one of the electron jumps when it approaches the benzene free radical, so that there are 2 electrons that make up a bond, and that electron is written as such. So as I said, it is a free radical. Look at this, free radical nucleophilic. Which is the nucleophile? Nucleophile is this. Substitution reaction. What has been substituted? The diazo. The diazo group has been substituted. Free radical nucleophilic, this is nucleophile. Substitution reaction, the substituted something, this thing is the diazos, right? Now electron is generated. Let us now go to step 3. Step 3, oxidation of Cu plus, Cu2 plus, cupric ion. We know in the first step cupric ion was formed. Cuprous gave electron to benzene diazonium salt and cupric ion was formed. This cupric ion now reacts with excess of electron in the system and it become back cuprous ion. So this cuprous ion now can react with excess of chlorine which is plenty available in the system, and it can become CuCl. So the catalyst is, again we got the catalyst back, it doesn't participate in the reaction. Dear students, these are the 3 steps of this mechanism. I hope you have understood the mechanism well. Now let us go to the synthetic importance of Sandmeyer's reaction. Synthetic importance or synthetic or applications. What is the first application? Yes, you don't have any doubt. I suppose it is used in preparation of the aromatic halides. Okay. What is the second application? Yes, there are 2 applications. It is also used in the preparation of aromatic nitriles. Shall I show you how to make nitrile? Shall I? If you give me the opportunity, yes, I will be glad to do so. N2Cl, if you are treating it with Cu cuprous cyanide, if you are heating it, you will get a benzonitrile, right? Now if you are, now N2 gas is also evolved, okay. Now if you are doing hydrolysis, acid hydrolysis, what would you get? A cyanide group will turn into COOH group. So you can make an aromatic acid also using Sandmeyer reaction, okay, indirectly of course. So you can make an aromatic halide directly, you can make an aromatic nitrile directly, and you can make an aromatic acid out of the aromatic nitrile that you have made. These are the synthetic applications of your Sandmeyer's reaction. Dear students, if you have understood and if you have liked the class, please do not forget to subscribe the channel. Thank you very much.